Hello. Today I'm going to show you how to add two vectors, not necessarily parallel, not necessarily the same. So let's see that let's see, we have these two vectors, 120 Newton, and in the east direction. Let's say this is x and this is y, so in the x direction, and the other vector, so let's call this f1 and this f2, and the other vector f2 or at 30 degree from the x-axis. The magnitude of f2 is 40 Newton, right? Okay, so how to add these two vectors? There are two ways. The first one is probably the easiest way, which is graphically. So we are going to use the tip and tail. So basically we draw F1, and from the tip of F1 we put the tail of the F2. It would be nice if I change the color. So this is F2. I have to keep the same magnitude and the same direction. Then the resultant vector, basically, we start from the tail of F1 and I go straight to the tip of F2. So this is F2 and this is FR, the resultant. Okay. And I can use a ruler basically to measure the length of this, the resultant vector, which is the magnitude, and I can also measure the theta direction of this, the resultant vector. So this can be done on millimetric paper or any other scale that you may have, and you can visually, or using tools also, you can measure all what you need. Basically, for each vector we need magnitude and direction. It's very important, especially in case of in physics, the forces. We always want to see what's the resultant force applied on a certain object. So this is a graphical way here, graphical way. And the second way is, this is first way, the second way is algebraic way. Okay, so here it's much involved. So I'm going to start with F2 because F1 is very simple because it's parallel to Fx of the x-axis. So for F2, I need to find F2x and F2y. Since F2 has this direction, so basically we'll have two components. This is one F2x on the x-axis, and this is F2y on the y-axis. This is theta, which is 30 degree. Now, we have F2, right? We have the magnitude of F2. How to get F2x and F2y? So basically, from this right angle, look at this right angle. If the cosine, so looking at this theta here, cosine theta equals the adjacent over the hypotenuse. Adjacent of hypotenuse. And this gives me F2x over F2. From here, because I know theta, so we can, and this is the unknown. This is our unknown. From here, we can do F2x equals F2 cosine theta, which is 40, I believe, 40 Newton times cosine 30 degree. So what is cosine of 30 degree? You can calculate that using the calculator, and this will give me 34 Newton. That's F2x. Now, what about F2y in the y direction? This guy here, the component of F2 in the y direction. So we take sine theta, which is opposite, the opposite over the hypotenuse. And this gives me F2y over F2. Then from here, F2y equals F2 times, because the hypotenuse is F2, right? Sine theta, which is 40 Newton times sine 30 degree. And using your calculator, you can definitely find F2y equal 20 Newton. Okay. Now, what about, let's go back now to F1, which is equals 20 Newton parallel to x-axis, right? This is F1. What is the component of F1 on x-axis? So F1x equals actually F1 because it's parallel. This is F1. It's parallel to x, the x-axis. So theta equals 0 degree. Now F1x equals F1 times cosine of theta, which is F1 times cosine of 0 degree, which equals 20 Newton, because a cosine of 0 degree equals 1. What about F2, F1y? Basically, F1 doesn't have any component on the y direction because it's parallel to x. If I take the sine, the angle between F1x and F1 and x-axis is theta equals 0. So if I take the sine of the angle, F1y equal F1 times sine theta, which is 0, then equals, this is 0, then F1 times 0, which is 0 Newton. So F1 has only one component in x-axis, which is clear. We don't have to do this because it's parallel to x-axis. I'm just showing you here using the theta. And now we have, so for our resultant, FR, our resultant, we have FRX and FRY. So FRX equals sum of f-axis, okay? Then we have F1x plus F2x. And this gives me, what is F1x? F1x equals 20 Newton plus F2x 34 Newton. It's already calculated, 34 Newton, and this equals 54 Newton. For FRY, so FR resultant, so this is the component of the resultant force on y direction. So equals the sum of Fy in the y directions, the sum of the forces on y axis, and this gives me F1y plus F2y. Remember, F1y equals 0, and this gives me 0 Newton plus 20. Is it 20 Newton? F2y equal 20 Newton. And this basically 20 Newton. So these are the components. These are the components of Fr. So if I draw them, this is going to be my Fr, and this is the component in x-axis, which is 54 Frx, 54 Newton, and this component here is Fry, which is 20 Newton. Now what I don't have here is theta. What is direction of Fr, the resultant force? So I got the component, the force components from F1 and F2, but what I'm missing here basically is the theta, is the direction, right? So, and the magnitude, because these are only the components on y-axis and x-axis. So from this right triangle, this is a right triangle, so this is the hypotenuse. These are the two sides, the adjacent and the opposite. So using the Pythagorean theory, Fr, let's move it up to here. So this is Fr, the resultant force. So Fr equals square equals Frx square plus Fry square. This is from the Pythagorean theory. So Fr equals square root of Frx plus squares, of course, plus Fry. Okay, and squares also here. So I just need to plug the numbers. Basically, I have 20 Newton squared plus 54 Newton squares. Okay, so, and if I do the math, I just need to use my calculator and do everything basically. So this will give me 57.58 Newton. That's my Fr. Now, what about the theta? From this right triangle, we can say that, let me change the color here, tangent of theta equal the opposite over the adjacent, right? That's basically the tangent of the theta, the opposite over the adjacent. And I have them. What's the opposite? It's Fry over Frx, right? And I have even the numbers, so it's 20 Newton over 54 Newton. So theta equals the inverse of tangent or arctangent of 20 over 54, and your calculator will give you a theta of about 20 degrees.